Hi folks, my name is Amit Singh. I'm a technical marketing engineer and I'll be talking about Cisco Catalyst Instant Access today. So hopefully you guys are familiar with the Nexus platform and maybe know of technology on the Nexus platforms we have called FEX satellite. So this is based on that. If you're not aware of it, I'll go through and explain it. But this is based on that, but it has certain specific enhancement, and it's actually meant for more of a campus use case, and it's supported on the Catalyst platforms. So we launched it in Cisco Live Orlando, and I'll go through and explaining what's the logic and reasoning behind it and what's the use case. So right now what you see is more of a traditional legacy network where we had spanning tree running in, where you had basically certain set of VLANs taking one physical path, and those VLANs are blocked on another link, your regular spanning tree, as you know. So we evolved from this when we introduced VSS. With VSS, you do not need spanning tree. Spanning tree was removed from your topology, and you used multi-chassis ether channel to actually do traffic forwarding as well as redundancy. So now your traffic switchover was not based on some spanning tree topology change notification coming in, but instead based on ether channel switchover. So we removed spanning tree. We basically, what VSS is we take two switches, we connect them back to back, and we basically there is only one control plane on those two switches. The forwarding plane is separate, and they are doing independent forwarding, but there's only one control plane. So that was the second step. So with Catalyst Instant Access, what we have done is we've actually taken the distribution layer and the access layer and now integrated it, and now we have a single control plane for the distribution as well as the access layer. So what are some of the advantages? So obviously it simplifies your network. You just have a single point of management, single point of configuration, single point of troubleshooting across your distribution and access blocks. Also, another advantage of this is that you get Catalyst 6500 features now at access. I'm sure you guys are aware of 6500 has been around for quite some time, and actually supports a lot of features, I would say. So all of those features, even advanced features like MPLS, can now be actually, if you're, let's say, deploying a routed access network, you could actually deploy VRFs out here in the access switches itself. So I actually have a demo where I've configured VRFs directly on the access ports of these instant access clients, and I'm doing traffic forwarding within the VRF, and I'll show you that demo later on. So
you're saying Cat 6500 features at access. I'm assuming this is a Cat 6800 product set, though, right?
So we support this is called the parent and this is the client. So the parent could be Catalyst 6500 or 6800. In terms of
there's some line cards that are making that happen.
Yes, so I'll go through those. I have a slide which you can use it for reference, but you require SUB2T as the supervisor, and then we have a specific line card called 6904 or 6904, which is required and which has the capability of adding that header to do the, basically it's called VN-tag header, which is required to do the encapsulation. Okay, and again the goal is consistent feature and agile infrastructure across layer. So imagine if you were managing it in Cisco Prime, you would actually be seeing just one switch. When you actually telnet into the device and actually show you, you actually telnet into one single device, and you can configure. At introduction, we support 1,000 ports on one distribution block, so you could actually configure all of those 1,000 ports from one single telnet access itself. So single point of management and configuration. So to go into a little bit more detail, more use case example out here. So here we have a traditional, whether it could be layer 2 or layer 3 campus, with 4 buildings, right? Each having 1,000 users access ports. So for total 4,000 user ports. Just doing some basic calculation, you have 168 access trunk ports and port channels that you have to configure, and total 94 devices for image management and configuration. So you have to telnet into those many devices, and you have to upgrade the software for those many devices. So, but that's more of a traditional or legacy network. You have things like stacking that you can introduce. So let's say you introduce stacking on the access layer switches. Now you reduce the total number of devices that you have to manage to 34. trunk port and port channel configuration 48. You still have those many number of user ports. Now we go and move one step further, just like I showed in my first slide, right? You add VSS onto the topology. Now we've removed spanning tree. You do not require, because it's single control plane in the distribution layer, you don't require HSRP, VRRP. No routing protocol tuning is required. Your redundancy is now based on ether channel redundancy rather than based on ECNP based redundancy, which could be dependent on number of routes, or even layer 2 convergence could be based on the number of MAC addresses you may have in switch. So this is what we had till now, but in Cisco Live Orlando we added the capability of campus instant access. Now you're basically managing only 5 total devices for configuration management. Automated trunk port configuration is done for you, and you still have the 4,000 user port. So now you're actually only managing 5 devices in a 4,000 user network. Again, no routing protocols or spanning tree running between the access and distribution. And you don't need to configure anything. All the switches show up as line cards on the switches, and I'll actually show it to you on a real live setup that I have running.
Aren't there limitations with number of child switches you can deploy?
So to start off with, we support 21 switches that you can deploy. 3 of them, if you want to stack them, maximum 3 can be stacked together to start off with, and 1,008 ports to start off with. In future releases, we will enhance this capability and increase the scalability of the number of ports.
Right now, the 1,000 ports is the limitation, and 4,000 is the goal.
So if I go back to this topology, each has its own distribution block. Right? So this is its own domain. This is its own FEX domain, I would say. So here you have 1,000 users, here you have 1,000 users, there you have 1,000 users. So if you have the multiple distribution blocks, each distribution block can have its own set of 1,000 users, and those numbers are going to get increased in the future software releases.
You just said FEX domain. I mean, and to me this sounds just like FEX with 2,000 going down to 5,000 or 7,000, and it's even VN tag.
Yes, so same concept. In fact, if I go through the CLI, you will see some of the same CLI as well. So CLI we've kept the same. So if you're aware of, most customers have data center and campus, obviously. So you want to kind of maintain the CLI the same, so customers are used to it. So the same CLI, same concept, except there are certain changes that it's not supported on the data center side because it's not relevant out there, but it's relevant to campus. So for example, we support PoE ports as well on these access plans, which is relevant to campus, obviously. We support stacking, again relevant to campus. We also support the capability of actually connecting switches, like one of those compact switches directly to these switches, which is not, because in the data center side, you're expecting server ports directly to connect to the switches.
You can't have switch off the FEX, but you can.
You can do that here because it makes sense in campus scenarios.
Is this local switching, or does this all have to go back down to the head end?
The hardware is capable of it, but it has to go down to the parent. It has to go down to the parent to do the switching.
Okay, so there is no local switching at this point.
No. There is the silicon supports it, but there's no local switching right now.
Okay.
There are certain enhancements we've done on the multicast side, for example. Even though the multicast is majority of it is handled in the distribution, for replication we actually do use the local engines to do the replication, so you can scale much more better. So for multicast, there is that enhancement that is there.
Can a Nexus 1000V or VMFX be part of this?
No, this is only relevant to the Catalyst product family. So I'll go through the products.
Well, VMFX is an extension of FEX into the virtual environment. Will that work?
No, this is only specific to the Catalyst family, as I mentioned. So you require 6500 or 6800 with SUB2T at the distribution block, and the new switch which we launched with software release 15.12 SY, the Catalyst 6800 IA.
Since it is VN tag, is it technically possible to connect the Nexus 2000 to this in the data center for a smaller campus? Or smaller network?
Theoretically, yes, but you won't be able to connect it because, again, as I said, it's you need the 6800IA, which is the...
Would that be roadmap, do you think? Again, if it's the same technology, same type of VN tag encapsulation?
No roadmap whatsoever.
And going back to the local switching, there's no local switching on the instant access, or is there a roadmap to do it? Because this is what I heard in the Cisco line. I may misunderstood it, but is there a roadmap to do local switching, to allow local switching instead of going back to the head?
There's no confirmed roadmap right now, so I would say that's where right now the switching happens in the back.
Okay, all right.
What about broadcast replication? Is it the same as multicast? Or
Broadcast application, yes. I'll have to confirm that. I know for sure multicast, we have the capability of doing it on this access switches. Broadcast also should be the same, but let me get back and confirm that. I don't want to go ahead and give an answer.
does it broadcast somewhere else in the network? Does it, send one stream down to the effects, and then does the effects replicate it? How does that?
So yes, with multicast we do have an enhancement where you can replicate it on the access switches itself.
Yeah.
Broadcast, yes, that would be the ideal scenario where it actually sends it to the parent switch, and parent switch does the replication.
So, I mean, I must be missing something, because this just sounds like it's never going to actually work alongside the virtual or virtualized layers in the cloud at all. It's all physical.
This is a
great.
campus design, though.
Yeah, but I have a campus cloud. I don't have physical switching all over the place.
User-facing stuff, you mean?
User-facing stuff could be this way, could be any number of ways. I mean, this is only part of the picture. I'm looking half the picture.
What do you use today in terms of?
Nexus 1000Vs, I use a bunch of stuff.
No, but for the campus, for the users.
Users are just actually wireless access points going on some standard switching network. Yeah.
So you
you're
can
great.
connect.
But again, this is only half the network. What's the other half doing? How can I integrate this across everything? So I have one control plane for everything.
All right.
You're missing, now I need two control planes, which again, you need two
Yeah, you
different sets of
still got two different domains, the data center domain and the user domain.
But they're separated, going forward, they're separated more than they have in the past.
Yeah, that's typical.
Yeah.
I mean, that's...
Well, in certain hybrid clouds, that actually may not be possible to separate, because now I'm transferring all my traffic over networking hardware more and more often, in, out, and basically crossing all sorts of boundaries here.
Okay.
Did you say you had a demo you wanted to get to? Let's go to the demo and see kind of how this works.
We don't have too much time.
Yeah, so I just wanted to quickly show the hardware requirement. So that's the IA client.
Is the IA client a brand new switch, or is that like a makeover of an older switch?
For all practical purposes, it's a brand new switch.
Practical purposes, or about non-practical?
It's a new switch, 6800.
It's a 6800 IA.
Yeah,
right?
Yeah. It's called 6800IA. Again, we have PoE, non-PoE models. 6904 is where the VN tag encapsulation is done, and you require sub-2T. And again, it works with 6807 as well as 6880X, which is the fixed at the 6800 that we have recently introduced. So I'll quickly show you a demo. So actually I have it running on the 6800, but again, as I mentioned, it works on 6500 as well, as long as it has sub-2T and 6904 line card.
So you can still deploy a Cat6K with sub-2T 6800s in there.
Yes.
Just the IAs have to connect back to the 04.
Yes. So there are two 10 gig ports available on the 6800 IAs. Those have to connect to the 6904 for the encapsulation. So I have a pretty simple topology up here. There you go. Pretty simple topology. I have two FEX switches, as you can see out here, FEX 101 and FEX 102, just connected to a quad sub based VSS.
You can call them FEX.
So this is actually a quad soup setup. Not sure if you're aware, we also launched capability of supporting quad soup in VSS, meaning now each chassis can actually have two supervisors, and the redundant supervisor in the chassis is actually in a new state mode that we call it, which is chassis SSO, or chassis basically. So 4 supervisors are now synced in chassis SSO mode. So for certain use case scenarios where you may have service modules or single home devices, they can also be connected and they won't lose connectivity. So if I go into the configuration of one of the 6800 IA ports, so as you can see, the FEX ID is 101. So let's look at the 101 FEX switch. So the way you look up the interface configuration, or you go ahead and configure it, is just you add the FEX ID, and then you have your regular interface numbering scheme. So So as you can see out here, I've configured VRF on switch EVN basically. I've configured EVN, which is a Catalyst 6500 feature, now being configured directly on the IA access port itself.
What customer type do you see adopting this versus instant access, converged access? 4K versus 3850 versus like a smaller pod, limited to 1,000 ports in a domain. You know,
I see a lot of customers who need something simpler in their network. They just want, maybe it's a branch network where you have maybe 500, 600 users to start off with. You may grow in the future, but you have 500, 600 users. You don't want too much to configure. You're fine with centralized wireless out there instead of UA. Not too much intelligence required maybe on the actual access switches down there. Even though you can still achieve a lot of intelligence because you transfer the Catalyst 6500 features out there. So those kind of users, maybe VDI deployments, I would say, BPO deployments, a lot of those use cases.
I'm just thinking, I guess, longer term. There's always been that evolution, stackable platforms, so it's always been nice. 37s, 38s, and beyond. And this, I guess, just the evolution of this. Can you speculate what would be like Gen 2 of this? Because the 6K's been around forever. Now it's the first time ever being integrated as like effects architecture. That here to stay for the next evolution of access switching.
I wouldn't say it's the next evolution, and so we have, I would say, two sets of solutions. So I actually have a slide, but I won't bring up the slide instead. I'll just say it. So we have two sets of solutions. One is the unified access with the wireless controller capability embedded onto the 3850 switches, more scalable in terms of just the number of access points and networks you can deploy with it. This is meant for customer use cases where they actually require a very simple network topology to manage. Just imagine, as I was giving an example of Prime, or imagine an SDN controller, right? Instead of managing 90 switches, it has to now manage 5 switches. Same with Prime, now instead of managing 90 switches, it has to manage. So less back and forth between the switches, so we're reducing basically overall network management requirements for the switches. And this is basically my traffic generator. So I'm basically just forwarding traffic back and forth between two interfaces on the board. On the same switch, I'm basically doing local switching. The other interface is so as you can see, they're part of the same word, and I'll just do a switch.
Since these are access switches, if I'm running a bunch of desktops and sending the switch guys, will they auto-forward a bunch of traffic to their location?
Sorry, could you repeat that?
If the switch is going down or it has a problem, will it drop out, will the control plane drop it out of the net so that another switch picks up that traffic?
Your users, which are connected to that physical port, they will go down.
Which switch are you talking about? The head end, the core, or one of the edge switches?
One of the edge switches.
Yeah.
It would be kind of nice if they could.
Yeah, but
A much more virtualized networking way.
The user's going to be staying home.
But even if you're doing virtual right now, even if you're doing everything virtualized right now, the access switch which connects to the access point, right? If that goes down, you can have everything else virtualized. But if that switch goes down, you don't have physical connectivity, right? So you need the first step, which is the physical connectivity. You can virtualize it, in front, but
Once it's a switch,
there's no physical connectivity. You
once
cannot.
the switch isn't actually dead, it just has the ability to forward packets. Somebody that's configured it or whatever. Can it be self-healing in some way? I can continue working.
There are certain features here, so it actually treats the switches like a module almost, so it's OIR based. So for example, there is very unlikely possibility of you putting the wrong image in there. They have a protocol which makes sure that it reboots it, so it actually comes down like a line card. So when you plug in the switch, it's like into the network. It actually plugs in just like a line card being plugged in onto a modular switch. That's how it works. So very rare possibility of something like that happening.
Okay.
Unfortunately, we've got lunch coming any second now. In fact, I think they're waiting in the hall.
So that's it for my demo. I just wanted to show some local switching using VRF and showing that capability being, 6500 VRF capabilities now being able to be configured.
On upgrade in IA, do you have to reboot the core?
No, we have the typical stack, rolling stack upgrade capability option available, or you can upgrade the access switch images one by one as well. Also, the images are basically packaged in Catalyst 6500 image itself. So again, you don't have to manage multiple images.
I was just talking that per campus, let's say with a couple IDFs, for them not to have impact on the core to upgrade their IDFs.
No.
Okay.